Hello friends, I am Chandan. Today I am going to start fluid mechanics subject that is very important for GATE, ESC, SSC, ISRO, DRDO, BARC and other competitive exam. The chapters are the first chapter will cover that is fluid properties. Second chapter pressure measurement. Third chapter fluid kinematics. Fourth, fluid dynamics. Fifth, flow through pipe. Sixth, laminar pipe flow. Laminar pipe flow. 7, boundary layer theory, very important chapter. Boundary layer theory. 8th chapter hydrostatic force of flat and curved surfaces. Hydrostatic force on flat and curved surfaces. Okay. And the last chapter will be dimensional analysis. Okay, so except dimensional analysis, the above 8 chapter that is very important for GATE exam, and you must complete the above 9 chapter that is important for any competitive exam, mainly GATE, ESC, SSC, JEE, ISRO, DRDO, BARC and other competitive exam. So first chapter that is fluid properties, important chapter, and in every exam there is a 1 and 2 question from fluid properties chapter. Pressure measurement also very important chapter. Fluid kinematics important chapter. Fluid dynamics, it is also important chapter. Flow through pipes, laminar pipe flow, it is also important, very important. And boundary layer theory, very important chapter. And it is also important, that is hydrostatic force on flat and curved surfaces. So these are the important chapter. So first I start the first chapter, that is fluid properties. So we'll understand what is fluid properties. First, what is fluid mechanics, and we will understand what is fluid and what is solid, and what is the difference between fluid and solid. We'll discuss in today's lecture. So start with the fluid properties. So our first chapter, that is fluid properties. So this is our first chapter. So first we have to understand what is fluid mechanics. The fluid mechanics is the subject. It is a science that deals with the fluid matter like liquid and gas. So fluid matter, it may be liquid or gas. So here, what is fluid mechanics? The science which deals the fluid matter, that is liquid or gas, in a static or in motion. Okay. Now we'll understand what is fluid. Fluid show continuous deformation under shear stress. So first focus on the solid. Okay, first focused on the solid. So suppose this is the solid bar, and in this solid bar, the length of the solid bar, that is L. Okay. Now if you apply some force, the length of the bar increases. So after application of some force, the length of the bar increases. Suppose the length is L plus delta L. Okay, so this is the delta L is the increasing length. Okay. Now, so this is the bar here, this is the bar, and after due to some force applied, the length is increases. Now if you want to calculate the linear strain, epsilon is the linear strain, then that is equal to change in length by original length. So what is the change in length? So L plus delta L is the final length minus original length by what is this? By total length. Okay, so from here epsilon, that is equal to delta L by L. So what is epsilon? Epsilon is the linear strain. So epsilon here, this is the linear strain. So important. Now there is one law, that is Hooke's law. So Hooke's law states that stress is proportional to strain up to elastic limit. So here Hooke's law states that is stress sigma, that is proportional to this linear strain. Okay, so this is the Hooke's law. So from here, so there will be a proportionality constant. Suppose it is E into epsilon. So from here you can calculate E, that is equal to sigma by epsilon. So what is E here? E is the Young modulus or modulus of elasticity. So we are focusing on the solid, not the fluid here. So after that we will compare what is the difference between fluid and solid. So from here E is the Young modulus or modulus of elasticity. So this is the Young modulus, very very important, Young modulus or modulus of elasticity. Modulus of elasticity, very very important term in strength of material. Modulus of elasticity. So this is the Hooke's law. So stress is proportional to strain up till elastic limit. So here sigma is the stress. Okay. Now if we draw the stress strain curve. Okay, if you draw the stress strain curve, so what is the stress strain curve? So here this is one axis, this is the horizontal axis, this is the vertical axis. So in horizontal axis there is a epsilon, that is a linear strain, and there is a sigma in y axis. So for stress strain, if we draw the stress strain curve for solid, focus on the mild steel. Okay, so here first the curve will be linear. The stress is proportional to strain up till one point, and then the stress decreases, and then the stress increases, and then the stress increasing like that. Okay, so this point is the fracture point. Okay, now here up till this point, so up till this point, so here stress is proportional to strain. So here the Young modulus E is constant up till this point. So this region is called elastic region. Elastic region. Okay, and here this point to this point, so this is the plastic region. Very, very important. This is the plastic region. Okay, and here the Young modulus is not constant. In every case the Young modulus is changes. Okay, now so if we focus on the Hooke's law, stress is proportional to strain, and E that is equal to sigma by epsilon. So if we focus on the rigid body, for rigid body, so what is the given case? If stress is greater than 0 and strain is tends to 0, so what is the Young modulus? So we know the formula, E that is equal to sigma, E that is equal to sigma by so E that is equal to sigma by epsilon. So sigma greater than 0 and this is tends to 0. So what is the value of E? E tends to infinity. So here the E that is Young modulus tends to infinity. Okay, now so suppose there is solid, this is the solid here. So if you apply shear stress tau that is equal to constant, for constant shear stress, so there is a shear strain. Okay, so phi is the shear strain. Okay, so here tau is the shear stress and phi is the shear strain. Okay, so there are another law, that is there is also another law, that is Hooke's law. So shear stress tau proportional to phi, this is also Hooke's law. Hooke's law. So there will be a proportionality constant tau that is equal to g into phi. So from here g that is equal to tau upon phi. So what is g here? G is the modulus of rigidity. Very very important. This is the modulus of rigidity. Okay, now if we focus on the fluid, if we focus on the fluid, so suppose there is a fluid on the solid surface. So this is the fluid here, and if you apply shear stress like tau that is equal to constant, then you see that suppose at t equal to, at some time, the shear strain that is phi 1, okay, so this is t1 and time t1. After some time the shear strain that is phi 2, and after some time, so this is time t2, and after some time t3, the shear strain that is phi 3. So what is happening here? The shear strain that is a function of time. Important case here. So here the phi that is equal to is a function of time. Very very important. So from here Newton's law of viscosity is coming into the picture. Okay, so from Newton's law of viscosity, Newton say that tau proportional to d phi upon dt. Okay, so here d phi by dt, it is the rate of shear deformation. So it is a rate of shear deformation. Rate of shear deformation. So what is this? This is the Newton's law of viscosity. So this is the Newton's law of viscosity. Important. So from here there is a proportionality constant coming into the picture that is equal to mu into d phi by dt. So from here mu that is equal to tau upon d phi by dt. So what is d phi by dt? d phi by dt is the rate of shear deformation and tau is the shear stress. Okay, so if d phi by dt increases, so d phi by dt increases, then what is the mu? Mu is decreases. So what is mu? Mu is the viscosity. Mu is what? The viscosity, dynamic viscosity. Okay, so if I draw the shear stress and rate of shear deformation graph, so the graph will be, so this is the rate of deformation d phi by dt, and this is tau, and so here this is for mu1, this is for mu2, and this is for mu3. So here mu1 greater than mu2 greater than mu3. Okay, now consider on a solid surface there is this is the solid surface here. On this solid surface there is a fluid, and there is another solid surface. On that there also another fluid. So consider this is fluid 1 and this is fluid 2. Now, so here this point, that is A1, B1, C1, D1, this is A2, B2, C2, D2. Now suppose you apply shear stress that is constant, and here also you apply the shear stress, it is also constant. So tau, this is tau equal to constant. So for fluid 1, so at tau equal to constant, the shear strain may be like this. So this is the shear strain. So here this is d phi 1. Okay, now at the same time, so if you measure the distance, suppose this is dx1. Okay, this is dx1, and this point, that is a1 dash, and this is b1 dash. Okay, now at the same time, so here tau equal to constant for fluid 2, the shear strain may be like this, maybe. So this is a2 dash, this is b2 dash. Okay, and this distance, that is dx2. So here this dx1 is greater than dx2. So for fluid 1, the dx1 is greater than dx2. Okay, now this is d phi 1. Okay, so here you see that is d phi 1 is greater than d phi 2. Okay, at the same time, d phi 1 by dt and d phi 2 by dt, which will be greater? This will be greater. So if d phi by dt is greater, then mu will be less. So mu 1 less than mu 2. So this is mu 1 and this is fluid 2, this is mu 2. It is a property of the fluid. Okay, mu is the property of the fluid. Okay, now so here you see that dx1 is greater than dx2. So from here dx1 by dt must be greater than dx2 by dt. So from here you can say that u1 is greater than u2. Okay, so important concept. Now there are another property, that is fluidity that is equal to 1 by mu. It is a property of the fluid, important. And compressibility, we will discuss what is compressibility and bulk modulus. Just remember compressibility beta, that is equal to 1 by bulk modulus, important, bulk modulus k. So this is also important. Now, so what is the difference between solid and fluid? So we'll discuss the difference between the solid and fluid. Okay, so for this is considered, this is the solid here and this is the fluid. So if you apply tensile stress for solid, sigma is the tensile stress. Okay, so due to this tensile stress, there is a tensile Young modulus coming to the picture in solid. So it will oppose the material, the solid material, due to tensile stress. Okay, so what is opposing here? So here, so it is opposing. Okay, so what is opposing? That is tensile Young modulus. But for fluid element, if you apply tensile stress like sigma in that direction, tensile stress, there is no property for fluid, no property. Okay, now for solid, there is another element for solid. So if you apply the compressive stress like this, then there is a compressive Young modulus coming to the picture. So here there is a compressive Young modulus, C for compressive, E for Young modulus. Okay, compressive Young modulus coming to the picture. But for fluid, so here this is also fluid element, and if you apply the compressive stress or pressure in that direction, this is the pressure, or you can see that minus sigma. Okay, so here the bulk modulus is coming to the picture. So if there is a tensile stress, there is no property for fluid, but if there is a compressive stress or pressure, there is a bulk modulus is coming to the picture. So bulk modulus K is the bulk modulus. Okay, next another solid, this is the solid element, another solid element, and if you apply shear stress, okay, there will be a opposing property is there. There is a G is coming to the picture. And what is G? G is the modulus of modulus of rigidity is coming to the picture. And for fluid element, so this is the fluid element. So for fluid element, there is a shear stress there. So there are the viscosity is coming to the picture. So mu is the viscosity coming to the picture due to the shear stress of the fluid element. So due to that, the fluid motion started or created. So in fluid mechanics, we'll discuss, it is a science which deals with the fluid matter, that is liquid or gas, in a static or in motion. So in fluid mechanics, we'll discuss the liquid and gases, and in this chapter we'll see that what is the difference between solid and fluid. Now the fluid, the matter whose existence defines pressure and which show continuous deformation under shear stress. So fluid show continuous deformation, because in this graph you see that here, so after time t1 the shear strain, that is phi 1, at time t2 the shear strain is phi 2, at time t3 the shear strain is phi 3. So in solid, for the given shear stress, there is a given shear strain, and fluid show continuous deformation under shear stress, that is the shear deformation. It is a function of time. Okay, so here it is a function of time. So in fluid mechanics, the rate of deformation is more important than deformation. So in fluid mechanics, the rate of deformation is important, is more important than deformation. Okay, now the viscosity, it is a property of the fluid which offers resistance to movement of one layer of the fluid over another adjacent layer of the fluid. So what is viscosity? Viscosity is the property of the fluid, the property of a fluid which offer resistance to movement of one layer of the fluid, one layer of the fluid over another adjacent layer of the fluid. So viscosity is the property of the fluid, and we discussed that the solid can oppose tensile, compressive and shear load. Fluid has negligible resistance for tensile load. They oppose the compressive load due to bulk modulus and shear load due to viscosity. Okay, but the property, that is viscosity, observed in fluid motion, that is very, very important. So this is about the basics of fluid mechanics and the difference between solid and fluid, very, very important. So I uploaded in description section all my this fluid properties handwritten notes are there. This is useful for this is free notes, and this is useful for GATE, ESC and other competitive exam. You go on my description page and download the fluid properties handwritten notes that is available in the description. You can go there and download it. And if you have any problem, I have the mechanical Bengali telegram group, and I have a mechanical Bengali WhatsApp group, so you can join that, and you can directly message me on WhatsApp. And you can message me for any inquiry to crack any competitive exam, to how to succeed in competitive exam. You can message me, and if you have any doubt, you can message me. Okay, thank you.